Okay, guys, let's get straight back into our marking. Just needed to be in two videos because I was worried it wouldn't upload if I tried to do too long of a video all at once. So we'll get straight back into question number 10. Question number 10, there was actually a question like this on a GCSE paper. I can't remember if it was in November or last year, and lots of people stumbled on it actually. It's because you're trying to get from 2/5 to 1. And it's like, what do you times 2? How can you make it 5/5? That's essentially what you're trying to get to, is 5/5 to be 1 to n. It just doesn't really work. So what you have to do is you've got to say, well, it's 2/5 to 4 and divide down to 1/5. It's almost like a proportion ladder question. Yeah, divide it down to 1/5, and then you can, by dividing by 2, then you can actually times that, by 5. If you then times that by 5, you'd get up to 5/5, and 5/5 would be the same as 1. Okay, so you've got to divide by 2 first of all. Well, that would give you 1/5 to 2. Then, as I said, we've already written our plan on this side, times by 5, and that's going to give us 10. So 5/5, 10. So your answer is 1 to 10. Okay, slightly funny sort of question there. And don't forget, guys, just pause it so you can green pen and wrap your head around it as we go along. Okay, question 11. Question 11, you need to translate your English into maths here. Okay, there are 54 pupils on a school trip. 54 pupils. Underline your key things. For every 6 pupils, there needs to be 1 teacher. Notice how I've translated my English into maths already here. There are 10 teachers going on this trip, so I'm going to say, okay, well actually, there are 10 teachers. Notice how I'm setting this out, one on top of the other, because that's very clear to me that that is times by 10. Are there enough teachers if there are 54 pupils? Well, let's work out, if there are 10 teachers going, how many pupils could theoretically go? If we times by 10 on this side, it's times by 10 on this side, which means theoretically up to 60 pupils could go on the trip. So if up to 60 pupils could go on the trip and only 54 are going, well then yes, there are enough, because they could take up to 60 pupils. Okay, could take up to 60 pupils. For your mark allocation there, guys, it would be a case of just saying, well, you'd get 1 mark for noticing that it's times 10. You'd get another mark for saying, yeah, they could take 60, and a final mark for your conclusion. Yes. If you just put yes and you don't put everything else, you can't have the mark. Okay then, guys, finally, question 12, So the ratio of Abby's savings to Bethany's savings is 5 to 6. Let's straight away start translating our English into maths. So Abby to Bethany is 5 to 6. But we're also told that Bethany to Carol is 4 to 3. So 4 to 3. Now the problem here is that these are not the same. Okay? You've got to make these so that these are the same. You need to find the lowest common multiple of this 6 and 4 so that these two can be compared. What I'd do is I'd say, well, the lowest common multiple of 6 and 4 would be 12. So let's times this one by 2 and times this one by 3 here. Well, 5 times 2, that would say that Abby's got 10. We've said this middle section would be 12. And this one, 3 times 3, that's 9. Notice what I've done there. I've just rewritten both of those ratios in equivalent ratios so that that 4 and 6 matches up with that 12 in the middle there. And then everything else is adjusted accordingly. Okay? Find the ratio then of Abby's savings to Carol's. Well, that's those two together. Abby is 10, Carol is 9. So your answer, 10 to 9. Okay, then last question then. Your last question. Ignore this challenge down the bottom here. I changed my mind about putting it in there. Okay, so question 13. I'm just trying to make it bit better focus for you. Okay, the ratio of bikes to cars in vans in a parking lot is 4 to 5 to 11. Okay, I'm actually going to draw out this situation straight away. So I can see that bikes would be 4. I can see that cars would be 5. Notice how I'm doing it exactly one on top of the other, so that I can see exactly that cars is just 1 box extra. And then to vans, I can see as 11. So this one needs to be really quite long. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That was quite neat. Okay, so if there are 24 more vans than cars, so you've got to think, well, how many boxes more are there of vans than cars? Well, it's these boxes, and that represents 24. If there are 24 more, and we're wanting to find the total, we need to use that information to work out what goes in each box. How many extra boxes are there? There's 6 extra boxes. And 6 extra boxes represent 24. So well then 24 divided by those 6 extra boxes tells me that there's 4 in each box. If we know there's 4 in these boxes, well then there's 4 in all the boxes. We can fill that in everywhere. This question is tricky, so make sure you might have to listen to my explanation more than once. So there's 4 in all the boxes. Well, how many? Then first the total number of cars and bikes and vans in the parking lot. Oh, hang on. If there are 24 more vans than cars, then first the total, I think that's meant to say then find. Then find the total number of cars and bikes and vans in the parking lot. Well, think about it. How many boxes are there altogether? We've got 4 plus 5 plus 11. That's a total then of 20 boxes. 20 boxes with 4 in each box means that there are 80 altogether in that parking lot. Okay, Year 8, that is all for today. Please could you make sure you have green penned everything. Do drop me any comments of things you are stuck on. Remember that in each of these things there is the Hegarty Maths clip numbers so that you can go and check and make sure you understand before you move on. Good luck with your real KPI tomorrow, and don't forget you will need to submit your scores. Thanks a lot, Year 8.